Dobrý den. My name is Christophe Fourtet. I'm one of the founder of Sigfox, and I'm going to narrow a little bit my presentation compared to the previous presentation, because indeed I'm going to focus on what we are providing to the IoT world, so basically a network for very simple IoT device. I often say that after 5-6 years of military radio communication device, I've been spending 15 years of my life increasing the data rate from GSM to 4G, and then decreasing the efficiency, the radio and energy efficiency of what I was doing. And then after 15 years, I decided to go back to something very simple that might be able to cope with extremely simple device and extremely low cost, low energy device. And that's all about Sigfox, basically. I might have started, as we are talking about IoT, showing you very sophisticated domotic device, funny weather station that you can connect to internet, etc., etc. This is not the Sigfox focus. We are being focused on what we call the massive IoT. And we've been hearing a lot about digitization. What is digitization for? We think that it is for measuring the world. So basically measuring something which is by essence analog, our environment, and to have a better knowledge of what is around us. So that's why I'm presenting this kind of image, where you have potentially some trashes, engines, a cat, a fire in a forest, a fisherman's, whatever. And that's basically what we are, where we are putting our focus. Getting information from systems that you would not have believed to be connected one day. Because why connecting trashes, or let's say collecting device for trash? Why would be monitoring containers? Why would be monitoring letters, parcels? This is feasible now. A few examples of what we might do with the massive, what we call the massive IoT, is having an idea of your perishable goods. What is the status of them? Route of deliveries, for instance. Where is my container? You know that a lot of people are wasting a lot of money because they don't know when the container is exactly arriving on a port. It's a bunch of money. Meaning that if you can have a very simplistic device that enables you to know where is actually your container, you can gain a lot of money. You can have a huge return on investment. Stolen vehicle, etc., etc. We could discuss forever about those kind of simplistic applications that you would not have even imagined to connect in the past. And the three pillars for that has been our focus since the beginning, is simplicity. Simplicity of the device. And I will go a little bit more on this later on. But also reliability and global. Global meaning that you make a device in a country, for instance in Slovakia, and you can go wherever you want. It's the same contract. No roaming. No roaming. No idea of having your device being stressed by where am I? Do I need to discipline the network? No, it's transparent. There are paradoxes behind that and rationals. In fact, you want to have as low cost network as possible, so you want large cells. But this is not very compatible with low power, simplistic device. You also want to use free spectrum because you need to know that one GSM channel, so 200 kilohertz somehow, costs something like, in a country like Slovakia, something like 10 million euro a year. to operate. So there is no way you can make a return on investment with such a cost. So you need free spectrum, which are unpredictable spectrum, because you have a bunch of devices. You might have a bunch of devices in the future on it. And you want to minimize the protocol. You want to have your object very simple, but you still want a carrier-grade performance, which means that we've been having some presentation on cognitive technique, and that's what we do, in fact, in the network. We need cognitive technique. We need to replace some form of intelligence that was made by human in the past. For this, you cannot prevent me to be a little bit technical. I'm an engineer. You need the right waveform. And the best way is the rain. The best way to drain a cloud with millions of tons of water is to use rain. That's exactly what we do in the resource. In fact, all those little dots are tiny message. And guess what? This is a GSM channel. Instead of passing one message at a time, we can pass thousands of messages in the same amount of spectrum. So for this, you need also cognitive techniques. In fact, you need artificial intelligence in your network. And you know, this is a very, very simplistic, old-fashioned transmitter, probably in the 1920 or something like that. This is the kind of transmitter that military or the people in the boats were using to transmit very simple information. We need these, we are in danger, blah, blah, blah. It's extremely simple, and the way you send an information is that you press a button or not. It's a Morse code type of transmitter. Was it efficient? Yes, extremely efficient. You could have long distance and very reliable transmission with this, with a very simple device, in a spectrum which was extremely occupied. Why? Because you had intelligence. You had people with their cognitive capability able to establish those very complicated type of transmission. In fact, what you need to do, you need to, as it has been exposed by Gert previously, you need to replace that by automation through computer science. And that's what we do, basically. So we can connect very simplistic devices. This one is extremely simple, thanks to the kind of intelligence in the network. So basically, a network is roughly this: radio and back-end server, front-end server. You need to put intelligence everywhere. In the radios, so that they can sort out the signals, they can make a lot of complex signal processing, like the people were doing with their buttons in the past. You need to put intelligence in the back-end server, so that you can reinforce signal, you can make some data processing, is this signal good or not, is this signal genuine or not, etc., etc. And you put intelligence in the front-end server up to the customer, because you can make data processing, big data, etc., etc. There are also questions of security in the and by the way, the best way to ensure security is to mix a lot of processes, even some kind of analog processes, and not only digital processes. In fact, the main word for us is that we make a network as a service, meaning that it's no longer a network which puts disciplines on a device, and the device is stressed by applying this discipline before exchanging any information. It's more a network which provides the relevant tools so that an idiot device is going to be extracted from the analog world. Basically, a network at your service. And I could probably make a very simple demo of that before I finish. You see, this is a prototype we did 6 years ago, roughly. It's one of the first network testers, so it's really handmade, I would say. And the first thing I did when I arrived here in Slovakia, because I'm going to show you that there is a network in Slovakia indeed, I made a test. It was my first time in Slovakia, and arriving at the border, I pressed the button. So the device was doing nothing. It was just sleeping, not taking care about the fact, is there a network or not? And I was informed that my message arrived in the system. As simple as that. No protocol, extremely transparent. because of all this intelligence we've been putting in the network, so that we can address simplistic, very simplistic and low cost, low energy usage. And to finish, that's an idea of the coverage in Slovakia, which is ensured by SimpleCell, one of our partners that has been making a great job. I can tell you that the network is really well performing. This is just an example of Slovakia. Indeed, you might make product here in Slovakia and send it all over Europe. It will work with no stress and no complex question about roaming and having a complicated contract. Thank you.